Hi again. In this lesson, you'll continue to learn more about object creation and storage, also known as instantiation. Constructor signatures look a lot like method signatures. The first part is the name of the constructor. Unlike a method, which can have any name, the constructor's name must be identical to the class name. Class and constructor names typically start with a capital letter, which makes it easier to spot among methods that will start with a lowercase letter. Like methods, the parentheses contain a list of input parameters. The arguments from the constructor call statement must match the order and type of parameters in this list. Constructors must always be declared as public so that other parts of the Java program can access them and call them to create the objects. You may have noticed that constructors don't have any return type listed, whereas all method signatures needed one. That's because Java knows that whenever a constructor is called, an object of that class type is returned. In other words, whenever the rectangle constructor is called, Java knows that it will always be returning a rectangle object. Just like methods, constructors can also be overloaded. For example, maybe there's a version of the constructor that only takes one input length to be used for square rectangles. There can be more than one constructor in a class, as long as each parameter list is unique. Now that you know what a constructor is, let's create another rectangle object. At the top here is the code that you've seen before. You are creating a rectangle variable and initializing it with a new rectangle object. On the bottom is a snippet of a rectangle class, with the attribute instance variables at the top, followed by one constructor. Let's run this program and follow its execution. The program starts in the main method, executing this first line. Since it is calling the rectangle constructor, the execution now moves into the rectangle class and to the constructor signature, where the argument values are passed to the parameters using call by value. Call by value initializes the parameters with copies of the arguments. Again, it's important that the argument order and data type must match the order and data type of the parameters. If they don't match, an error will occur. Next, the execution moves into the constructor, assigning the parameter values to the attribute variables of width and height. Now you can see how the parameters help the constructor give each object its own set of attribute values. Once this process is done, the execution returns to the point where the object was created and continues from there. In this case, the new rectangle object reference is assigned to the variable rect1, and then the program terminates. One thing to note here. At this point in the course, you don't need to know the details about how to create your own class or set up the inside of a constructor. You can use a pre-written class, like rectangle, to create an object by identifying the arguments that are required for that class's constructor. After that, you are free to use your new rectangle object however you'd like in the rest of your code. In an upcoming lesson, you'll learn how to access and use the methods stored in each object so that you can put them into work. Let's take a look at this last scenario. Here, you declare a rectangle variable on the first line in the main method and actually create and assign it the object reference on the second line. So the question is, what is the default empty value of a reference variable like direct1 if it hasn't been assigned an object reference yet? Well, let's add a print statement after that first line to find out. If you run this program, you'll see that a null value is printed. Going back to our computer memory visualization, you can see that until the object is created, the variable rect1 holds a value of null. You can think of it like a placeholder or an empty reference. Then, when the object is created and assigned to rect1, the object is stored in memory, and its reference gets stored in rect1. Now it's your turn to practice object creation and storage.